Alright, so here's an example using position vectors to find the resultant force. So again, I've got two forces here. I've got a force B going from A to B along some cable, 600 newtons, and force C, which is 450 newtons, going from A to C. Okay, and I want to know the magnitude of those two forces added together, the resultant force that's acting at A. Okay, so I start with vector B, and again what I'm going to do is I'm going to take that force vector, the 600 newtons, and I'm going to multiply it by the unit vector going from A to B. A unit vector, again, is magnitude of 1, basically just gives me the direction without changing the magnitude. So to find that unit vector, I just find the position vector from A to B, okay, and divide it by its magnitude. Now, moving from A to B, okay, again, it's just final minus initial in all of the x, y, and z components. So B is at -5 in the x direction, okay, minus +5 in the x direction for point A. Okay, so B is at -2.5 in the y direction, okay, minus a -1.5 in the x direction. Okay, and K in the z direction, B is at 2, A is at 0, so 2 minus 0. So the way I actually generally do this is say, okay, how much do I go from A to B? And I see I go 0.5 plus 1.5, so I go 2 in the x direction. Okay, in the y direction I go -1, because I go from -1.5 to -2.5, and in the z direction I go up 2. So I would just call that, what would I call that? I would call that -2, -1, 2. Okay. So square root of that is just going to be the square root of the sum of the squares. That gives me the magnitude of the position vector. And I'm left with my unit vector, which is just -2/3, -1/3, and +2/3. And again, if I took the square root of the sum of the squares of this, I'd find that the magnitude of this is 1, which is what a unit vector is. So that's the unit vector from A to B. Now I simply multiply that times the 600 to get this force vector. So I'm writing the force vector B in Cartesian form just by taking the 600 newtons times the unit vector from A to B, given right here. So I take the 600 times -2/3, 600 times -1/3, 600 times 2/3, and I get -400, -200, plus 400. So that's the vector form of FB. And again, I'm doing the same approach that I do with any vector addition. Write each force in Cartesian form, sum up the x, sum up the y, sum up the z. So I'm starting by writing the forces in Cartesian form. So now I have to do the same thing for C. So I start with the unit vector. So in the x direction, I move, let's see here, I move 0.5, so I move -2 in the x direction. In the y direction, I move 1.5, so I move 2 in the y direction. And in the z direction, I go from 0 up to 3.5, so I get 3.5k. So basically I get -2, +2, 3.5. So taking the square root of the sum of the squares to get the magnitude, I get a unit vector of -4/9, +4/9, +7/9. Taking that unit vector times the 450 gives me my force vector for C. So I take 450 times -4/9, get -200, 450 times 4/9, +200, 450 times 7/9, +350. Okay, so at this point now it's very simple. I've got my force vectors written in Cartesian form. To find the resultant, I just sum up the i's, sum up the j's, sum up the k's, and I get a resultant vector of -600i, which is -400 minus 200. My j's cancel, and I get 750k. So finding the resultant of that, I just take the square root of the sum of the squares, and I get 960.47 newtons. So again, write the forces in Cartesian form, sum up the x's, sum up the y's, sum up the z's, take the square root of the sum of the squares to find the magnitude. To write those forces again, it's just the magnitude of the force times the unit vector, which is the position vector, divided by its magnitude.